Hey, Algebra 1, Mr. Schachter back at you with the definition of a greatest common factor. So what exactly does that mean when you're trying to find a greatest common factor? Here's the definition. The greatest common factor is known as the largest positive integer that divides evenly into a couple of numbers. Okay, so it's the largest positive integer that divides evenly into those numbers. Let's try a practice example. I want to find the GCF between 30 and 144. So the easiest way to do this, to be honest, is to either, one, use your divisibility rules and narrow it down, or two, use their prime factorizations, okay? So I'm going to do it using the prime factorizations. So let's take down the prime factorizations of 30 and 144. So if I break down 30, it's going to be 3 times 10, and I'll circle 3, and 10 is 2 times 5. So the prime factorization of 30 is 2 times 3 times 5, okay? And then I break down 144. Well, I know 144 is 12 times 12. And each of the 12s could be 2 times 6, 2 times 6, so I'll circle my 2's. And each of the 6's is 2 times 3. And that's as far as I could take the 6. So I circle, circle. And so the prime factorization of 144, I have 1, 2, 3, 4 2's. 1, 2, 3, 4 2's. So I did these. And then I have 3 times 3 as well. And if you actually checked and multiplied all this out, that actually would equal 144. So we got 4 2's and we have 2 3's. Well, the greatest common factor is simply the number that each of them could remove. So you can't take any more than you have. So for example, if you look at the number 2 here, I'll use a highlighter to show my place here. 2. The number 30 had 1 2. And the number, 144 has 4 2's. But you can only take out the smallest number. Okay, you can't take out more than you have. So in the GCF of these two numbers, if I were to start writing down what the GCF would be, it's going to contain 1 2. Okay? And then I look for 3's, and I ask myself, all right, I've got 1 3 here, and I've got 2 3's here. So I can only take 1 and add it to my GCF. Add it to my GCF, so I'm going to put a 3 here. Okay? And then I look for 5's. You're going to notice that this number, the 30, has 1 5, but the 144 has 0. That means I cannot add any 5's to my GCF. Once you're done playing this game, the GCF is simply whatever 2 times 3 is, which is 6. So the GCF of 30 and 144 is equal to 6. So the prime factorization helps if it's not a simple GCF you could figure out mentally rather quickly.